Hello my good people, welcome to my YouTube channel. This is Filipino explaining. In this video we are going to learn inverse functions. What's an inverse function? An inverse function is a function that will undo anything that the original function does. For example, consider the function fx is equals to 2x minus 5. If we take any value of x and plug it into fx, what will happen to the value of x? First, the value of x will get multiplied by 2. For example, if we plug in here 1, it will be multiplied by 2. If we plug here even 5, it will be multiplied by 2, and then we will subtract 5. The two mathematical operations that are taking place in the function fx are multiplication and subtraction. So now let's consider the inverse function. What two other mathematical operations will be needed to undo fx? Division and addition will be needed to undo the multiplication and subtraction. A little further down we will find the inverse of fx. We'll have an example. This is what I'm trying to say. We'll have an example to find the inverse of this fx equal to 2x minus 5. And hopefully, as I have said, the inverse function will contain both division and addition. So notation: if fx represents a function, then the notation f inverse x, the notation is read as f inverse of x will be used to denote the inverse of fx. Similarly, the notation g inverse x read as g inverse of x will be used to denote the inverse of gx. NB, I'll say an NB that f inverse of x is not the same as 1 over fx. And it's very important not to confuse function notation with negative exponents right there. So what you have to know is that not all functions have an inverse, so it's important to determine whether or not a function has an inverse before you try and find the inverse. If a function does not have an inverse, then we need to realize the function does not have an inverse, so we don't waste time trying to find something that does not exist. So how do we find if a function has an inverse? To determine if a function has an inverse function, we need to talk about a special type of functions called a one-to-one function. A one-to-one function can say that it's a function where each input x value has a unique output y value. To put it in another way, every time we plug in a value of x, we will get a unique value of y. The same y value will never appear more than once. A one-to-one function is special because only one-to-one functions have inverse function. So we can note that only one-to-one functions have an inverse function. So we can look at examples so that you can understand very well and get it clear what I do mean. For example, if we want to determine if the function f, which is equals to 7 3 8 negative 5 negative 2 11 6 negative 6, sorry, it is negative 6, here is positive 4. For example, such a function is a one-to-one function. So example 1. So from the look of things, the function f is a one-to-one function because each of the y values, this for xy, 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 xy. So each of these y values in the ordered pairs is unique. None of the values of the y values appear more than once. You can see just 3, negative 5, 11, 4. Since the function is a one-to-one function, the function f must have an inverse. Second example, you can see you're asked to determine if the function h is equals to negative 3, 8, 11, negative 9, 5, 4, then 6, negative 9 is a one-to-one function. As you can see, the function h is not a one-to-one function because the y value of -9, you can see here I have -9 is not unique. The y value of -9 appears more than once since the function h is not a one-to-one function. The function h does not have an inverse. Remember that only one-to-one function has an inverse. Okay, so as we have seen, we can say that we can determine if functions are one-to-one by looking at ordered pairs and determining if each of the y values is unique. But what if we do not have ordered pairs? We will create ordered pairs by plugging different x values into the function and finding the corresponding y values, giving us ordered pairs. Rather than spending time creating ordered pairs, why not consider looking at the entire graph of the function instead? By looking at the entire graph, inside graph, we have to draw a graph of the function, of the graph that represents a function, rather than a few points. Then we will still be able to determine if the function is a one-to-one function or not by just looking at the entire graph right there. So in looking at the entire graph of the function, we can determine if a function is a one-to-one function or not by applying the horizontal. There's something called the horizontal line test, or HLT. If the graph of the function passes the horizontal line test, then the function is a one-to-one function. But if the graph of the function fails the horizontal line test, then the function is not a one-to-one function. So we can note here that horizontal line test. The horizontal line test says that that a function is a one-to-one function if there is no horizontal line that intersects the graph of the function, that intersects the graph of the function at more than 1 point. So by applying the horizontal line test, not only can we determine if a function is a one-to-one function, but more importantly, we can determine if a function has an inverse or not. Now let's look at an example to help us explain the horizontal line test, and we shall use just use our function here, fx is equals to 2x minus 5. Okay, so you can say example give fx is equals to 2x minus 5, this function. So we want to explain the horizontal line test if the function to show if the function or how the function passes horizontal line test or fails horizontal line test. So we plot a graph of fx against x, and this is the graph. So here is the graph of fx against x. So we can plotting it, you can say you can choose any values. When x is equal to 0, fx is negative 5, 1 2 3 4 5. So when fx is equal to 0, x is equals to 2.5, 1 2 2.5. I've just chosen those 0 when this is 0. You can use other values to plot the graph, not necessarily to use when this is 0 and the other no. You can use other values. So we plot, have plotted, now we draw. So here it is. I have drawn the graph of the function fx is equal to 2x minus 5. So if we draw a horizontal line, we draw a horizontal line so that to confirm if it's a one-to-one function or not. Here's a horizontal line drawn, horizontal line. So this line has cut the graph just once. However much you extend this line, this line, it will not. This line will not. This horizontal line will not cross it more than once. You can draw this line here or there, provided it's horizontal. Yeah, it's horizontal. So since the line cuts or crosses our graph only once, then it has passed a horizontal line test. It has passed a horizontal line test, and therefore the function fx is equal to x minus 5 is a one-to-one function, and hence it has an inverse. Remember, I've said that only one-to-one functions have an inverse function. So up to that point, we are done with determining if the function is a one-to-one function or whether it has an inverse or not. Now in the next video we are going to learn or to show or to work out some examples so that you can know how to find an inverse of a function. Inverse function of a function. On how to find inverse function of a function. Make sure you do subscribe so that anytime I upload a new video, you get a notification and you'll not be left out. Thank you so much for watching. Thank you so much. Till next time. Bye bye.